In this video, we're going to talk about ionic bonding. We're going to use multivalent metals. Multivalent metals are metals that can have multiple charges, so they can lose different numbers of electrons. Sodium, Na, always has a +1 charge. It will always lose one valence electron, never more, never less. So it is not multivalent, but there are plenty of metals that we don't know the charge right off the bat because they can have multiple different charges. So for example, iron, Fe, notice iron is located in the D block of the periodic table. It's number 26. It can lose 2 electrons and become Fe2+, or it can lose 3 electrons and become Fe3+. And just looking at Fe on the periodic table, we cannot identify that charge. We can only identify the charge based on the Roman numeral. So iron, when written in a compound, will be iron 2 oxide. That would indicate that this compound has iron that has a +2 charge, or iron 3 oxide, which would indicate that the compound has iron with a +3 charge. If you do not know how to write the Roman numerals 1 through 6, please make sure to copy these down, starting with number 1. 1, 2, 3, 4, 5, 6. So that is how we indicate the charge of our multivalent cation, our multivalent metal. So notice you can see the some of these charges. So like scandium generally has just a +3 charge, but titanium might have a +4 or a +3. Vanadium has a +5 or a +4. Chromium has a +3 or a +2. These are not charges you need to memorize at all. The D block, most of these are multivalent elements. So if I ever give you a compound that has manganese in it, I would have to tell you the charge of it. You are not expected to know. Versus if I give you a compound that has calcium, you need to know that all of our group 2 metals have a +2 charge. All of our group 1 metals have a +1 charge. But the ones in here, the ones in this D block, are complicated. They are multivalent. They can have multiple charges. So how can we determine the name of a chemical formula that has a multivalent metal? Well, we need to know the charge of the cation because we need to include it as a Roman numeral in the name. So there are 2 ways to determine the charge on the cation. The Lewis dot diagrams and the cation anion chart. So I'll show both of these ways and you can pick the way that you like more. So first we need to determine the charge on the anion. So I'll start with the cation anion chart. In this case, our cation is our metal. Our cation is always the metal. And in this case, it's copper. And I want you to notice that we have 3 coppers because we have that subscript 3 that indicates that we have 3 copper ions. Then our anion will be nitrogen, and we have 2 nitrogens because we have that subscript 2. If we look at the periodic table, we know that nitrogen is not multivalent. It always has a charge of -3, always. And so I can put that in. I know that my nitrogen has a -3 charge. I don't know my copper charge. It is multivalent. It's in my D block, and sometimes it's +2, sometimes it's +1. We don't know what it will be. So I know that my nitrogen is a -3, which means I have a total -6 charge. -3 and -3 makes a -6. I know that my charge for my copper has to be the same every time, and it has to equal a +6 because my charges need to be able to cancel. The positive has to be equal to the negative. So I need to think to myself, something plus something plus something, or something times 3 has to equal 6. So in this case, it would have to be a +2. I know +2 plus 2 plus 2 equals 6. Mathematically, I can think 6, right? There's my 6, divided by 3, because I have 3 coppers, has to equal +2. And that is my charge of my metal. Therefore, this name would be copper 2, because it's the +2, whatever the charge is goes in the Roman numeral, and then nitride. Remember to change the ending to IDE. Okay, so there's another way to do this. We can use our Lewis structures. So I know I have 3 coppers, again, same thing, and I have 2 nitrogens. Okay, I know that each nitrogen has a total of 5 valence electrons. Based on the periodic table, it's in group 5 or group 15. It has 5 valence electrons. Each nitrogen needs to gain 1 more electron. So what I'm going to start with is, and it's gaining those electrons. Each nitrogen needs to gain, 3 more electrons, so that it has a total of 8. And it's going to gain those electrons from copper. So I'm going to start by just giving each copper 1 electron. And this is how you should always start. Just give each of your cation 1 electron. And this copper is going to give to nitrogen. This copper is going to give it to nitrogen. And this copper is going to give it to nitrogen. Now, this nitrogen up here, my top nitrogen, has a total of 8 electrons, 8 valence electrons. So it's stable. That one's good to go. But down here, my other nitrogen still needs 3 more. So my 3 coppers did not have enough electrons to satisfy both nitrogens. So I'm going to give them each 1 more. And let's see if this works. Now these coppers can give their additional electron to nitrogen, and now this nitrogen also has a total of 8 electrons. So my coppers have given all of their electrons away. My nitrogens have gained a total of 8, so everything's good to go. And how many electrons does each copper have? Each copper has 2. So again, I would write the name as copper 2. The Roman numeral indicates the charge, or indicates the number of valence electrons that the metal's giving away. And then again, nitride for the ending. Make sure it's "ide." Okay, so now if we want to go the other way, determine the formula, the Roman numeral here is telling us the charge of the cation. So we just need to balance these charges. So again, you can use a cation-anion chart. So in this case, my cation is iron and my anion is bromine. Okay, this 2 indicates that iron has a +2 charge. And if I look at the periodic table, I see that bromine is in group 7 or group 17. So it's going to gain 1 electron. So it'll have a -1 charge. Well, I have a +2, -1. That's not equal. I have more positive than negative. Therefore, I need to add another bromine. And now my charges cancel. So now I have a +2 and a -2. That's stable. So my formula would be Fe. I wrote that once. Br2. I wrote that twice. You can also do the Lewis dot diagram, where Fe has 2 valence electrons that's giving away. Br is in group 7. Group 17 has 7 valence electrons. And so I'm going to transfer 1 electron to Br. Well, Br now has 8, but Fe still has 1 more electron it needs to get rid of. So I need to draw another Br with its 7 valence electrons. And then this electron is going to go to that Br. So therefore, again, I have 1 Fe and 2 Brs. So you can do it either way. And this is how you make ionic compounds with multivalent metals. Metals that can have multiple different charges, and we don't know the charge based on looking at the periodic table.